All right, guys, what we're going to talk about for this lesson is the Pythagorean Converse. So we normally use a squared plus b squared equals a c squared when we are given a right triangle. But the Pythagorean Converse actually proves that if the areas on the squares of the legs are equal, the area of the squares on the legs added together equal the square on the hypotenuse, that it actually is a right triangle. So instead of being given a right triangle, we're trying to prove it's a right triangle by using the Pythagorean theorem, which is known as the converse. All right, so if we were in class, we would actually have straws that I had cut up for you. So that's why it says take the straws out of the bag and measure them in centimeters. So we're not in school. You're not able to physically do it. So when you see a measurement in the table, I'm going to tell you what kind of a triangle it's going to form, because if you continue to read the directions, after you take the straws out of the bag and measure them in centimeters, you're supposed to see if your triangle forms an acute triangle, a right triangle, or an obtuse triangle. And I have what they are over here. An obtuse triangle, if you look, an obtuse triangle is a triangle that has one wide angle, an angle greater than 90 degrees. And here you can see it right there. A right triangle, you all know, has a 90-degree angle, and there's that right angle. But for an acute triangle, if I can get this to move, let me unlock it. I'm trying to get the page to slide, and it won't slide. Okay, let me try this. There we go. An acute triangle, right here, is a triangle where all angles are less than 90 degrees. All right, so like I said, we're not in class. So it's kind of hard to do this and assuming that, we're not in class. So what we'll do, I'm just going to tell you what kind of triangles these are going to form. So if you had the straws that were 3 centimeters, 4 centimeters, and 5 centimeters, like in this first row in the table, it would actually have formed a right triangle if you had those. If you were in class and you had those straws that had lengths of 5 centimeters, 12 centimeters, and 13 centimeters, it would have also formed a right triangle. If you had straws 5 centimeters, 6 centimeters, and 10 centimeters, once you try to put them together, it would have formed an obtuse triangle. 6, 8, and 10 would have formed a right triangle. 4, 4, and 4 would have formed an acute triangle. And this would have made more sense had we actually been in class. I'm sorry, guys. 1, 2, and 2, if you had those straws with those lengths, it would have formed an acute triangle. All right, so I've given you the straw part. Don't worry about that. If you just remember, if it's these measurements make a right triangle. These measurements make a right. These make an obtuse. These measurements make a right. And these two measurements make an acute triangle. So now what we're going to do is just fill the table in. So you have a squared plus b squared equals to c squared. So c is always the longest side. Well, here you have a squared plus b squared. These are your legs. Over here you have c squared, so that's your hypotenuse squared, which is the longest side. All right, so it's the longest side, C, but what we want to do in that first column, well, that third column there, is focus on the legs. All right, so the two shortest sides. So this has to be A, that's B, and this one is C. So all I want to do is take A and B and find the square of A and add it to the square of B. So that's going to be 3 squared plus 4 squared So we end up with 9 plus 16. 9 plus 16 is 25. So I'm just squaring the legs. Squaring the legs and adding together. If I square the legs and add them together, I get 25. Then I'm going to compare it. This is where you compare to C squared. Okay, over here. All right, so C in this particular case was 5. So 5 squared is, let me write that a little better. I don't like my 5 looking like that. So 5 squared is 25. So when I compare, here I have 25, and here I have 25. So this side, this number is equal to that number. All right, fill this in. Here, the two shortest sides are your legs, that's A and B, and the longest side is your hypotenuse. So you're looking at 5 squared plus 12 squared. Well, that's 25 plus 144, which is 169. And then you're going to compare it to C squared. C, in this case, is 13. 13 is 169. Well, what do you notice about these two numbers? Well, these two numbers are equal. So that means A squared plus B squared equals to C squared. All right, here, A and B are the two shortest sides. C is the longest side. So we're going to end up with 5 squared plus 6 squared and see what we get. That's 25 plus 36. And 25 plus 36 is 61. Now we can compare it to C. Well, C in this case is 10, so 10 squared is 100. But these numbers are no longer equal. 61 isn't equal to 100. 61 is actually less than 100. Remember, when you compare, you're looking at less than, greater than, or equal to. Let's look at the next one. That's A, B, and this is C, the longest side. So I'm looking at 6 squared plus 8 squared, because I'm just doing A and B squared like this says. A plus B squared. So that's 36 plus 64, which is 100. And then I'm going to compare it to C squared. Well, C is 10. So what is 10 squared? 10 squared is 100. Now, when I look at both of those, 100 is equal to itself, 100. So that means A squared plus B squared equals to C squared. In this particular one, A squared plus B squared, A squared plus B squared is less than C squared. All right, let's look at the ones where we have a cube. All of them are 4 in that next one. So you have A, B, and C. So that's 4 squared plus 4 squared. You're looking at 16 plus 16, which is 32. And C is also 4 squared, which is, C squared is 4 squared, which is 16. But 32 is not less than, but greater than 16. All right, and then here, A, B, and we'll let that one be C. So you have 1 squared plus 2 squared. That's 1 plus 4, which is 5. I'm going to compare it to the C. The C here is 2. So 2 squared is 4. Now when you compare those, 5 is greater than 4. So you put greater than there. All right, so you should notice something. So I'm going to highlight some of these things. If it's equal. Okay, this was equal. Let me make this bigger. This was equal. This one was equal. Okay, so 3, 4, and 5, they were equal. 5, 12, and 13, I have equal there. 6, 8, and 12, it was equal there. But notice, if they were equal, what kind of triangle did it form? Right, right, right. So when your A square, go back to this. When your A square plus B square equal to C square, then you ended up with a right triangle. Okay, now that's if A square plus B square equals C square. Now hold on. You got it. When you get it, just come and hit print. Right here, I'm gonna do it too. I'm done. I'm sorry, I'm working with the student. Okay, guys, I'm sorry about that. All right. So when a squared plus b squared equals to c squared, you ended up with a right triangle. All right, let's take a look at another one. Let's say, I'm trying to find something where you can still see it when I make the markings. Okay. Now, look at this one where you had less than. Okay, so where you had less than, 61 was less than 100. So that means a squared plus b squared is less than c squared. So where your a squared plus your b squared is less than your c squared, the triangle was obtuse. Okay, let's take a look at another one. Okay. Here you have acute and acute. All right, so let's take a look at the comparison. It was greater than. So basically, when a squared plus b squared was greater than c squared, you ended up with an acute triangle. All right, so I'm going to get rid of this pen with that marker and move this up. And we're just going to state what we have again. So what conclusions could we make? Well, our conclusions were when a squared pen please. When a squared plus b squared equals c squared, it proved that it is a right triangle. But when a squared plus b squared was less than c squared, it proved that it was an obtuse triangle. When a squared plus b squared was greater than c squared, it proved that it was an acute triangle. But basically, if you just focus on the Pythagorean Converse, the Pythagorean Converse states that if the square of the blank is equivalent to the squares of the blank, then the triangle is a right triangle. So the Pythagorean theorem says that the square of the hypotenuse is equivalent to the sum of the squares of the legs, then the triangle is a right triangle. That's what the Pythagorean Converse says. Now, I'll just expand it on the Pythagorean Converse because it can help you also find out whether you're looking at an acute triangle or an obtuse triangle. Okay. All right, so we're going to use these things right in here to help us with these. It says determine if the following side lengths form a right triangle. If not, describe what kind of triangle they form. All right, so let's take a look. All right, remember the longest side is C. So that's the longest side. So it has to be C. If I can get it to right now, that's C. And therefore these two have to be A and B. All right, and then we're not going to write A squared plus B squared equal to C squared because we don't know that yet. We don't know if it's a right triangle or not. I mean, it may not be. All right, so what we'll do is we got to compare to see what kind of triangles they are. So I'm going to use A squared plus B squared. Do not put equal. We don't know if they're right, and just put a blank, which means compare to C squared. It's going to write 9 squared plus 12 squared, and I'm going to compare it to C squared. Not putting an equal. I don't know what to put there yet, but definitely not going to put an equal because we don't know. All right, so now that gives us 36 not 36, 81 plus 144. And I needed to go back and fill this in. Hold on, guys. I don't want to put C squared because I actually know C. So I want to put C, which is 15 squared. I want to compare it to 15 squared. 15 squared is 225. Well, if I take 81 and add it to 144, I end up with 225. Now I can say these two sides are equal. And since they're both equal, I can say that the triangle is a right triangle. That stands for the triangle symbol, okay? It's a right triangle. All right, now let's take a look at these. The longest one here is C, is 17. So I'm going to let that be A. I'm going to let that be C, and that's B. So I'm going to compare A squared plus B squared to C squared. All right, so A is 12. 12 squared plus 9 squared. I'm going to compare it to 17 squared. That's 144 plus 81. I'm going to compare it to 289. Well, that gives me 225 compared to 289. Well, 225 is less than 289. If it's less than, it forms an obtuse triangle. If A squared plus B squared is less than C squared, it forms an obtuse triangle. All right, let's look at this one. That's A, B, and the longest side is C. So if A squared plus B squared compared to C squared, it's going to be 8 squared plus 15 squared compared to 17 squared. 8 squared is 64. 15 squared is 225. And I'm going to compare it to 17 squared, which is 289. What do I end up with right here? I end up with 289 is equal to 289. So these two are, this is also a right triangle. I'm going to add one more on here, guys. Hold on just a second. I'm going to add an extra one on here because I didn't get a chance to go over one that was acute, okay? I need it to be greater. All right, so if I gave you 4, 5, and 6, that would be A, that's B, and that's C. So 4 squared, well, let me go back and write A squared. Undo. A squared plus B squared, compare it to C squared. So that's going to be 4 squared plus 5 squared compared to 6 squared. 16 plus 25 compared to 36. Well, what is 16 plus 25? Well, it's 41. 41 is greater than 36. If it's greater than, it's an acute triangle. All right, and that's it for the Pythagorean converse. The converse says you can tell if it's a right triangle if A squared plus B squared equals C squared. And then I added on, you can also tell if it's acute if A squared plus B squared is greater than C squared. You can tell if it's obtuse if A squared plus B squared is less than C squared. All right, that's it. I stayed under 20 minutes.